Hi, today we will be talking about three different concepts of operation results. One is saddle point, second one is EMV and EOL calculation, and third one is decision theory rewriting the way of metrics. So first one is saddle point. Do you know what is saddle point? A saddle point is a point on a surface where the function is a maximum in one direction and a minimum in another direction. Simply a saddle. It is neither a local maximum or nor a local minimum. So here in the question, you are required to find the saddle point of the following game. So here the metrics are A1, A2, B1, B2. So in this way, we just see it as row, and this way we just see it as column. So in row wise, A1, 3 and 2, A2, 4 and 1. So the first step is to find what is the row minimum and column maximum in order to find the saddle point. So the row minimum is the row minimum. We are calculating the row. This is the row and this is the column. So the row minimum, the minimum of this row is 2 and the minimum of this row is 1. So next is column maximum, which means the maximum of the column. Okay, here the maximum of the column is 4 and the maximum of the column is 2. So we should find saddle point if the number in the column maximum and row minimum number comes equal. Here 2 has come in the column maximum and 2 has come in row minimum. So we have found a saddle point. So the saddle point exists in A1 and B2. So next is calculation of EMV and EOL. EMV means expected monetary value and EOL means expected opportunity loss. Expected monetary value is a decision-making tool used in risk analysis to calculate the average outcome of uncertain events by multiplying each possible outcome by its probability and summing the results. So in simple words, EMV is all about finding the maximum value and EOL is about expected opportunity loss is a weighted average of potential losses from not choosing the best decision calculated by multiplying each opportunity loss by its probability and summing the results. So EOL is uh, all about finding the lowest value. So first we will calculate EMV. I have given two different problems in order to find EMV and EOL. So probability value is one of the major thing which should be given in the EMV. So it will be given in the question paper. So EMV the metrics is A1 and A2, S1 and S2. So here we should calculate like x1 into p1 plus x2 into p2. Here x1 and x2 is seen as this matrix and p1 is and p2 is seen as this probability value. So S1 is 30 uh, and 30 and 20 and S2 is 35 and 30. So how to calculate? As I have told before, to calculate we should calculate like x1 into p1. So here x1 is when x1 is like I have calculated the value here. So here x1 is 30 and p1 is 0.6. Then we will get a sum of 80. And when calculating to here the x2 is 35 and p2 is zero point 0.4. So now we will add all these two numbers and we will get a sum of 32. Okay, and next is going to the second row, that is S2. Here x1 is 35 and x1 is 30 sorry, x1 is 20 into zero point 0.6, that means x1 into p2, x2 into p2, x2 into p2, 20 into zero point 0.6 plus 30 plus um, 30 into zero point 0.4. Okay, now we will get the sum of 32 and 24. So here we are required to find expected monetary value. So here we will find, it is all about, I have taught before, it is all about the maximizing value after adding this two numbers. We have got an answer of 32 and 24. Here the maximum value is 32. So EMV is 32. And next is EOL, which means expected opportunity loss. Here it is all about the minimizing value. Here we all the matrix is already given and the probability value is already given. As I have taught before, we just calculate it as x1 into p1 plus x2 into p2. So after calculating this, we just usually add which we have done before, and we will get the answer. So in the answer we select the answer which has the least value. Here the least value answer is zero point 0.8. So EOL, that is expected opportunity loss, is zero point 0.8. So as I have taught before, EMV for A1 is greater, so the decision will choose strategy 1, and the EOL for A1 is least, so we choose that. Next is decision theory rewriting the payoff matrix. So here it is the metrics are given here. So we have N1, N2, N3, S1, S2, S3, S1, S2, S3, and the metrics numbers are 700, 500, 300, 300, 450, 300, 150, 0, 300. So the next is here in this we have several things to understand. One is maximum criterion, a decision rule where the decision maker chooses the option with the best of the worst possible outcomes, focusing on minimizing risk. And next is max criterion, a decision making rule where the decision maker selects the option with the best of the best possible outcomes, emphasizing maximum potential gain. And next is mini-max regret criterion, a strategy that minimizes the maximum regret by comparing the regret opportunity loss for each decision and choosing the one with the smallest worst case regret. Laplace criterion, a decision rule that assumes all possible outcomes are equally likely and selects the option with the highest average payoff. So here the matrix is already given. So the first step we just use it maxi-min criterion. So to find maxi-min criterion, we just find the maximum of the minimum of maximum. Here we look at in the column wise. Here the minimum of the maximum is 150, as I have given below, and in the second column the minimum of maximum is 0, and the third column minimum of maximum is 300. So max, we are finding here the maximum of maximum. So in the first column the maximum of maximum is 700, the maximum of maximum is 500, and the maximum of maximum is 300. So the payoff comes like S1 is 150, S2 is 0, S3 is 300, and S1 is 700, which is when we are coming to maximax. S2 is 500 and S3 is 300. So next is max regret criteria. So here we prepare another regret table. So regret table is prepared like we just subtract this highest number with the smallest number. Okay, in each row wise. So here in the first row 700 is given. 700